Imagine, just for a second, a dynasty that ruled the entire globe.
Right.
And I don't mean for a few centuries, not even for a few millennia, but for 160 million years.
It's just staggering.
It really is. I mean, that is a stretch of time so unbelievably vast, our human minds genuinely struggle to comprehend it. For 160 million years, they were the undisputed kings of the planet. And then, well, in a single afternoon, they were utterly obliterated by a rock falling from space.
Yeah, it's basically the ultimate biological rug pull.
Exactly. So today we are taking you on a deep dive into that exact afternoon. No dry fossils, no dusty textbooks. Based on the timeline from our source, Apex Truth, we are doing a minute-by-minute playback of this apocalypse. We really want to unpack exactly how the apex predators of the Mesozoic era lost the Earth and how we eventually inherited it.
And it's such a suspenseful story, really. One moment you have absolute evolutionary perfection and dominance, the next, a total planetary reset. But to truly appreciate the scale of that reset, we have to start with the mystery of how we even know this happened.
Right, the detective work.
Exactly. How do we actually know what went down on a random Tuesday 66 million years ago?
So to unpack this, we have to look at a discovery from 1980, right? Our source mentions that scientists found this thin layer of clay in the Earth's crust, and it was spread across the entire globe, dating back exactly 66 million years.
Yeah, the KT boundary.
Right. And this clay was just absolutely packed with a metal called iridium.
Which is the ultimate smoking gun here.
Yeah.
Iridium is a very heavy metal. When the Earth was just a molten ball forming billions of years ago, almost all of our native iridium sank straight to the planetary core.
Oh, so it shouldn't be on the surface at all.
Precisely. Finding a global dusting of it right on the surface meant it had to come from an outside source. It is a space metal, commonly found in asteroids. So that global layer of iridium was the first concrete proof that the planet had taken a catastrophic hit from the cosmos.
And then, like a decade later, they found the actual wound, the Chicxulub crater, buried under the Yucatan Peninsula in Mexico, and it stretches 180 kilometers wide.
It's massive.
Yeah, and you add in recent discoveries from quarries in places like New Jersey. Paleontologists there have found these mass graveyards of tens of thousands of fossil fragments from creatures that all died simultaneously.
It paints a terrifying picture.
It really does. You start to get this highly accurate picture of a world that ended in mere hours.
But before we get to the explosion, we need to define that world. Because if you are picturing the late Cretaceous period as some barren, swampy wasteland filled with sluggish lizards, you are really missing the profound tragedy of what was lost.
Yeah, the source paints a totally different picture.
It does. Earth, 66 million years ago, was incredibly vibrant, complex, and highly evolved. The supercontinent Pangaea had mostly broken apart. If you looked at a globe from space back then, Africa, Australia, and Greenland were already taking their modern shapes.
It's wild to think about.
And you had massive mountain ranges like the Rockies and the Andes actively, violently pushing upward from the crust.
I was actually really struck by the climate details in the material. I mean, it wasn't just a global hothouse everywhere. You had ice caps at the poles, and places like prehistoric Alaska were seeing winter temperatures plunge to minus 45 degrees Celsius.
Yeah, it was a dynamic climate.
But in the more temperate zones, it was a world of thick forests. You had ancient conifers, sure, but also modern trees like walnuts and beech. And crucially, you had flowers.
The explosion of angiosperms, the flowering plants, it really cannot be overstated. It was a massive evolutionary leap.
Because they brought fruit, right.
Exactly. Flowers meant seeded fruits, which created these highly dense, energetic new food sources. And that drove the rapid evolution of insects like bees and butterflies, which in turn drove the evolution of specialized herbivorous dinosaurs, early birds, and, well, most importantly for our story, mammals.
I'm so glad you brought up the mammals because, I've always pictured our ancient mammalian ancestors as these terrified, shivering, shrew-like things just hiding in the mud from the dinosaurs.
That's the common myth, yeah.
But Apex Truth paints a very different picture. Mammals were actively diversifying and taking over very specific niches right under the dinosaurs' noses.
Oh, absolutely. They weren't challenging the T-Rex for the top of the food chain, but they were thriving. Take the Cronopio dendriacutus found in Argentina.
The saber-toothed squirrel.
Yes. It was this 20-centimeter creature, effectively a saber-toothed squirrel. It possessed a long snout and these massive, disproportionate fangs specifically adapted for piercing the hard exoskeletons of large insects.
Wait, hold on though. The source also mentions a creature called Ventana certici in Madagascar, and it describes it as a 9-kilogram marmot with bone crusts on its skull.
Yeah, quite a bit bigger.
I'm picturing a rodent the size of a bulldog. How does a ground-dwelling fuzzball that big not just become like a mid-morning snack for a passing raptor?
Because they evolved remarkable survival strategies. That thick bone crest on its skull provided robust attachment points for massive jaw muscles. This allowed it to process extremely tough, fibrous roots and vegetation that other animals just couldn't eat.
Ah, so they didn't have to compete for the same food.
Right. And they lived in deep burrow systems. They hid underground during the day and foraged when larger site-based predators were less active. They basically figured out how to live in the margins.
And some of them stepped out of the margins entirely, which is crazy. My absolute favorite is Repenominus. This was a 14-kilogram mammal, built kind of like a modern Tasmanian devil.
Oh, that one is fascinating.
Yeah. It wasn't just scavenging. The fossil record shows this mammal actively hunted and ate baby dinosaurs.
Which perfectly illustrates a fiercely competitive ecosystem. But, we have to keep the scale in mind here. An aggressive mammal snatching a hatchling is impressive, but the dinosaurs were still operating on a biological scale that just defies logic.
The scale is staggering. Let's look at the Alamosaurus. I mean, we are talking about an animal 29 meters tall, weighing 38 tons, with a tail alone that stretches 12 meters.
Like a walking building.
Honestly, I struggle to understand how a biological machine that large even keeps itself running. How do you pump blood up a 12-meter neck?
Well, it requires an internal cardiovascular engine operating at absolute maximum capacity, literally all the time. To fuel a 38-ton body, an Alamosaurus had to ingest up to a ton of vegetation every single day.
A ton, every day.
Every day. They weren't just grazing, they were basically biological strip mining operations. A herd of 50 would have to constantly remain on the move, stripping entire forests bare in a matter of days just to avoid starving.
Which means the predators had to be equally massive to take them down. And this immense daily calorie requirement is exactly what sets up the fatal dynamics on the ground just hours before the impact.
Because nobody is looking up.
Right. The ecosystem is operating perfectly. Down in the Yucatan Peninsula, a herd of those Alamosauruses are slowly wandering, tearing down trees. Meanwhile, in the floodplains of what is now Mongolia, a Tarbosaurus, a predator as long as a city bus with teeth the size of steak knives, is staking out a watering hole.
Life is proceeding exactly as it has for millions of years. It's completely unaware.
And as we sweep over to the coastal regions of North America, we find a 450-kilogram Pachycephalosaurus. This is the dinosaur with the 25-centimeter thick dome of solid bone on its skull.
Right, the dome heads.
Yeah, and it's wandering the shoreline, crunching on highly nutritious seeds and massive coastal ammonites. Not far inland, a mother ankylosaurus built like an armored tank the size of an African elephant, complete with a devastating bone club on her tail, is guiding her 4 cubs into the shadow of the newly formed Rocky Mountains.
It is a tableau of perfect ecological balance, which really makes the fatal encounter we see next so poignant, because it represents the absolute peak of dinosaur evolution.
Right before the end, we are in a North America forest, and a young Carnotaurus, which is a very fast, smaller meat eater, makes a fatal mistake. It wanders into the territory of a Tyrannosaurus rex.
A deadly mistake.
Now, I'm reading the stats here from the source, and the Carnotaurus can hit speeds of 50 kilometers per hour. The T-Rex maxes out around 40, so if the intruder is faster, how does it get caught?
Because raw speed means absolutely nothing if you don't know you're being hunted. The T-Rex's sensory adaptations were practically supernatural. Its olfactory bulbs were massive, allowing it to smell an intruder from miles away.
Oh,
And more importantly, its eyes faced directly forward.
binocular vision.
Precisely. Forward-facing eyes provide overlapping fields of view, which creates perfect depth perception. A T-Rex could calculate the exact distance to its prey with the precision of a modern hawk. It didn't need to outrun the Carnotaurus, it just needed to ambush it.
And the physical mismatch is just horrifying. I mean, the T-Rex weighs 7 tons. It outweighs the intruder by 5,000 kilograms. The ambush isn't a fight, it's a structural collapse.
That's over in seconds.
Yeah, the T-Rex's jaws were engineered by millions of years of evolution to shatter bone. It easily crushes the Carnotaurus. Then it needs every single bite because a creature that size requires 100 kilograms of meat a day. That's the equivalent of what 3 or 4 modern lions consume combined.
I think what's truly fascinating here isn't just the sheer violence, but the brutal irony of the moment. You are looking at a Tyrannosaurus rex, a creature wielding flawless sensory tools, unparalleled bite force, and immense muscular strength.
Right.
It is nature's perfect terrestrial killing machine.
But those perfect adaptations, the binocular vision, the bone-crushing jaws, the massive caloric engine, they are about to become its biggest liabilities. Because
Really?
10 minutes later, the sky tears open.
The asteroid enters the Earth's atmosphere.
I'm still trying to wrap my head around this. A rock that is 10 kilometers wide, it weighs several trillion tons. As Earth's gravity grabs it, it accelerates to 20 kilometers per second.
The speed is unimaginable.
It is. But here's where the physics get really interesting and kind of terrifying. I always assumed an asteroid that size burned up because of friction, like rubbing your hands together. But the source says it's actually about pressure.
Yes, it's a process called adiabatic compression. The asteroid is moving so insanely fast that the air in front of it physically cannot get out of the way.
Like it's trapped.
Exactly. The rock acts like a piston in a giant atmospheric engine. It violently compresses a 20-kilometer column of air down to nothing in a fraction of a second.
Oh, man.
And when you compress a gas that rapidly, it superheats. The air itself ignites to tens of thousands of degrees.
So the rock essentially wraps itself in a plasma field brighter than the sun. Back on the ground, the T-Rex pauses its meal, it looks up, and the light blazing across the sky is so intense that even when the predator instinctively squeezes its eyes shut, the light burns right through his eyelids, blinding it instantly.
It's a blinding thermal flash.
The radiant heat off this incoming fireball is so extreme that the grass and trees around the T-Rex literally burst into flames before the rock even touches the earth.
And then it slams into the shallow waters of the Gulf of Mexico.
If we connect that localized destruction to the bigger geological picture, how do we even quantify a blast that size?
Well, by looking at the scars it left behind.
Yeah.
The impact released energy equivalent to 10 billion Hiroshima atomic bombs detonating simultaneously.
10 billion. I can't even picture that.
In a single second, it displaced the ocean and punched a hole 20 kilometers deep into the Earth's crust. Think about the sound alone. The historic Krakatoa volcanic eruption in 1883 was loud enough to rupture the eardrums of sailors 70 kilometers away.
Right, I've heard of that.
The Chicxulub impact was 1 million times more powerful than Krakatoa.
The blast wave is beyond horrifying. It moves outward faster than the speed of sound. The pressure front is so violent it physically skins animals alive. It creates these localized hyper-tornadoes.
It's pure devastation.
You know how a modern hurricane can pick up a mobile home and suddenly its weight ceases to matter? That is what this blast wave did to 7-ton dinosaurs, just tossing them into the air like leaves. The T-Rex we were just watching dies instantly from a catastrophic mid-air concussion.
And that herd of 50 grazing Alamosauruses down the Yucatan. They were standing essentially at ground zero.
Oh no.
The instantaneous thermal flash vaporized their 38-ton bodies into ash before their nervous systems could even register the pain.
But the crazy part is, the initial blast is just the opening act. The Earth itself violently reacts. Let's check back in on our Pachycephalosaurus, the dome-headed dinosaur eating seeds by the ocean in North America.
He's quite a bit further away.
Right, he actually survived the shock wave, but he's standing next to the ocean. And that impact in the Gulf just displaced billions of tons of water outward.
Creating a massive displacement wave, a mega-tsunami.
A tsunami 100 meters tall. To give you some terrifying perspective on this, the horrific 2011 tsunami in Japan that devastated an entire nation was barely 10 meters high.
And this was 10 times that size.
Exactly. And it didn't just crash on the beach and recede, it rolled relentlessly across the continent. It pushed thousands of kilometers inland, completely flooding the future United States all the way into what is now North Dakota. The Pachycephalosaurus is simply swallowed by an inland sea.
While the oceans were consuming the coastlines, the tectonic plates were shattering. The impact triggered global earthquakes estimated at an 11.2 on the Richter scale.
Okay, we need to do the math on that, because an 11.2 doesn't instinctively sound like the end of the world to someone used to hearing about modern quakes.
It helps to remember the Richter scale is logarithmic. Every time you go up one full integer, the energy released multiplies by roughly 32.
Okay, so it scales up fast.
Very fast. The most powerful earthquake humanity has ever recorded was a 9.5 in Chile in 1960, which literally ripped the ground open. Going from a 9.5 to an 11.2 means we are talking about seismic tremors, roughly 500 times stronger than the most violent earthquake in human history.
That is unimaginable.
The entire planet rang like a bell.
And that intense shaking triggered volcanic eruptions all over the globe, which threw massive amounts of soot and ash into the air. But wait, what about the Ankylosaurus mother and her cubs in the forests of North America? They were hundreds of kilometers away from the ocean in the blast. I assume they would be safe from the immediate chaos.
They weren't, sadly, because of what was happening in the upper atmosphere. When the asteroid hit, it didn't just dig a hole, it vaporized 15 trillion tons of earth and rock and blasted it straight up into space.
But it has to come down.
Right, gravity eventually wins. That pulverized rock cooled into billions of tiny glass beads, about 5 millimeters wide, and started raining back down through the atmosphere.
Like billions of glowing meteors re-entering all at once.
Exactly. The collective friction of trillions of glass beads violently re-entering the atmosphere turned the sky into a broiler oven. The ambient air temperature at the surface spiked to hundreds of degrees. This atmospheric thermal pulse ignited flash fires globally.
So the thick forest the Ankylosaurus mother had let her babies into for safety just spontaneously combusts. They're incinerated in minutes. The fire is everywhere. Which brings us back to our Tarbosaurus hunting in Mongolia.
Who is very far away.
He is literally on the exact opposite side of the planet from the impact, but the disaster still reaches him.
A massive cloud of hot dust and gas races across the Mongolian plains at 18,000 kilometers per hour. The air temperature spikes well past the boiling point of water.
So how does anything survive that?
Well, the Tarbosaurus barely survives the initial thermal pulse by scrambling deep into an underground limestone cave, while that scorching glass rain pelts the surface above.
I'm looking at this absolute wasteland and wondering, what does this actually mean for biology? For the few desperate creatures like the Tarbosaurus that actually managed to survive the first 24 hours by hiding underwater or in deep caves.
It means they survived a swift execution, only to face a torturously slow starvation.
Oh, wow.
The impact vaporized hundreds of billions of tons of sulfur-rich rock from the Yucatan and injected it straight into the troposphere, which is the lowest layer of our atmosphere, basically where all our weather happens.
So that sulfur mixes with the atmospheric moisture,
Creating global, highly concentrated sulfuric acid rain. For weeks, corrosive acid poured from the sky. It poisoned the topsoil, acidified the freshwater lakes, and drastically lowered the pH of the surface oceans, wiping out massive amounts of marine life and the remaining vegetation.
And if the acid rain wasn't enough, you have the soot from the global wildfires and the volcanic ash forming this dense, impenetrable blanket around the entire planet. The sun was completely blocked out.
It was pitch black at high noon.
And without the sun, the global thermostat broke. Temperatures plummeted by an average of 28 degrees Celsius worldwide.
This is the impact winter. Photosynthesis simply stopped. The base of the food chain and the plants and phytoplankton died. And when the base collapses, everything above it falls.
So when our Tarbosaurus finally emerges from its cave in Mongolia, driven mad by thirst and hunger, it steps into a nightmare. The warm, vibrant, lush world it knew yesterday is just gone.
Completely gone.
It is freezing cold. It is completely dark. The only things thriving are decay, mold, and fungi, feeding on billions of corpses. The mighty apex predator, the king of Asia, just wanders this frozen wasteland until its massive biological engine runs out of fuel and it starves to death.
It is a profound evolutionary tragedy. The exact traits that made the dinosaurs untouchable, their immense size, their massive muscle mass, their high-performance metabolisms requiring huge quantities of fresh calories, became the precise mechanisms of their extinction.
They were just too big to survive the fallout.
Yeah, they were biological sports cars that suddenly found themselves in a world without gas.
But nature abhors a vacuum. And this is the great pivot of our planet's history. The losers of the Cretaceous period, those tiny overlooked creatures scurrying in the shadows, suddenly had the ultimate advantage: the mammals.
Because the mammals weren't sports cars, they were highly efficient hybrids. Their small size meant they could hide deep in insulated burrows, completely protected from the initial thermal pulse and the freezing impact winter.
And more importantly, their diets. I was fascinated by the concept of scavenger metabolisms in the source material. Because mammals were small, their caloric needs were a fraction of a dinosaur's.
A tiny fraction.
But beyond that, they didn't rely on fresh, sun-grown vegetation or massive prey. They were detritivores and opportunistic scavengers. They could survive by eating rotting roots, burrowing insects, and the fungi that were actively breaking down the dead world above. They basically bypassed the sun entirely.
They were infinitely adaptable, and as the atmospheric dust slowly dissipated over several decades and sunlight finally pierced the gloom to touch the Earth again, it was those small burrowing mammals that crawled out into light to inherit the ashes.
It's like a sci-fi movie.
It really is. Hardy ferns and grasses eventually sprouted. The Cenozoic era began, and from those few surviving mammalian lineages, the evolutionary tree rapidly branched out into every mammal on Earth today.
Including, eventually, us. It fundamentally changes how you view our place in the world. 160 million years of magnificent, untouchable dominance, wiped clean in a geologic blink of an eye. The entire planetary board was violently reset, just so you, listening to this right now, could eventually exist.
Looking at that turnaround raises an important question, doesn't it?
Oh, for sure.
The dinosaurs held the crown for 160 million years. We humans have walked this globe for only a tiny, microscopic fraction of a few million years. If another Chicxulub level event were to strike our planet tomorrow, instantly resetting the board again. Well, what small, overlooked creature living in the margins of our world today is perfectly adapted to inherit the Earth next?
Well, there is a thought to keep you up at night. The next time you see a squirrel darting into a hole, or a marmot chewing on a root, just remember they might be next in line. You break your arm, the x-ray tells you exactly what happened. But when it comes to the deep history of our planet, it takes a detective to see that the world we built our modern lives on was literally forged in the fires of an apocalypse. Thanks for diving deep with us.